So last time we started discussing use of numerical Python library, where mainly this package used for scientific computing, and also especially we used to represent vectors and matrices. Yeah, the other day told you like the usage of NumPy, and there are many other libraries built on top of numerical Python library. And here are like some of the key packages that you will see in various other, fields. For example, in quantum computing, you see Qt, PyQuil, Qiskit, and Penny Lane. Like these are some of the libraries available, and some of them are built on top of numerical Python. So likewise, there are other, libraries available, particularly for data science, machine learning, and visualization. So the very first thing that we have discussed last time is how do you, see or represent data in different way. In the first one, we have seen representation as a list, and then representation as a numerical Python array, or we call it NumPy ND array. So mainly we are using this is to efficiently work with the data or store in as vectors and matrices. So whenever possible, you should define them as numerical Python arrays. So last time we just look at some of the methods available in numerical Python. So we said import NumPy as NP, and then we created basically vector A. In this one, normally known as row vector. This is what we call row vector. Let me put a comment, row vector, because we have only 4 elements here. So when you run it, you will observe the outcome, which will generate a numerical Python array called A. And here are some print statement and some method calling. So in print A, we will print the array as it is. When you say type A, we will see the type of this array as a numerical Python ND array. Shape, that means number of rows and columns. Size, number of elements. And finally, last line, you are trying to access the first element, which is 1 here. Right. So let's continue our discussion. So today, let's start with defining what we call a column vector. Now, column vector, we can define like this. So let me say this is as P, and I'm going to use np.array method. And within this, I will put a list of list. For each row, we have one line. So we will have 1, right, comma, 2, comma, 4, comma, 5. So here is a representation. So now we can try printing B. So now you will see it printed as a column vector. So you can try other methods that we have discussed. Get the shape, number of the dimensions. So we can say, okay, print b dot shape. So this is number of dimensions, basically rows and columns. So it will show us, okay, we have 4 rows and 1 column. And then we can have b dot size, which represents number of elements, that is for right. If you finish up to this point, can you please raise your hands? Now that we have looked at how to create row vectors and column vectors, so let's look at some functions available you to generate vectors. Now this is important, and for example, in coming session, we will look at visualization, but then we need to generate data. So in this part, let's look at how we can generate vectors. So I'm going to look at function for generating vectors. Now the first one we are going to use is called arange. So arange function can be used to generate vectors is used by specifying start, stop, and step values, like in range function. So for example, let's say I want to create a vector starting with numbers from 1 to 10, right? So I will say in this one, let me put it as C, and then I will say, okay, np.arange. If you remember, printing numbers from 1 to 10, start we discussed should be 1. And when you put 11, it goes up to 11, not including 11. So when you say print C, now you should see that this vector C contains numbers from 1 to 10. So a small question, like if I say, let's say I want to print numbers from 1 to 100, what should be my Python statement? Can you share in the chat? Okay, thanks for sharing the answers. We got a couple of answers from Anjana, Prishantini, and Rakshani. So the command could be something like np.arange. We can say the start and stop like this, and then it should print numbers from 1 to 100. Okay, so can you give me the code for printing odd numbers then from 1 to 100? So what is the command for printing odd numbers for 1 to 100? Yes. What is the command for printing odd numbers? So you remember that there are three things: start, stop, and step, right? So we can say C equals NP dot A range. We can say 1, 100 and 1, then step we can make it to 2, right? So if you say print C, now you should notice that this will create a row vector which contains only the odd numbers from 1 to 100. Okay, good. What about even numbers? Okay, how about numbers from 10 to 1? Can you give me the code for these two as well? Okay, I'm going to share the code for even numbers. Good. What about the others? Minoli? So let's put C equals NP dot A range. The starting value will be 2 because you start with 2, isn't it? And then it should go to 101 because we want to have 100 as well. Then we have to put 101. And then we can say 2. So now if you print C, now we will see that this will print a vector, row vector containing even numbers from 1 to 1. Okay, similarly, what is the command to print numbers from 10 to 1? So we have to figure out what the starting value, then end value, right? And then we have to specify step value, right? Yeah. So let me put C equals NP dot A range 10 comma. If you want to print 1, then we should know that we have to put 0, right? So the default is 1. So because of that, we have to put -1. Yeah. And when you say print C, should give us numbers from 10 to 1. Okay. So just to summarize what we did, we use a range function what it does, it will create using a numerical Python. We can create a set of arrays based on start, stop, and step values. Okay, now the second one that I would like to discuss, there's another function linspace. Actually, what it means, linear space vector, right? So the function linspace is used to generate linearly spaced vectors. Now, for example, if you say, let's say y was np.linspace, and then we can say the 1 and 100, let's say, right? So what happens here, this will create a vector of 50 elements, right? Linearly spaced between 1 to 100. So let's print y. So now you can see, right? You see a set of numbers between 1 to 100. Actually, you can check number of elements. We can say print y dot shape. So you can see there are 50 elements. It says 50. So that is default value. Now that we have 100 elements, let's say if you want to specify how many elements you can have, simply what you need to do is we take a code. We will say y equals np dot linspace. We can say, okay, 1 comma 100 comma 100, right? Print y dot size, and then we can print y. So if you do that, you can now observe that this has the size is 100, or maybe we will put shape. So when I put shape, we'll get yes 100 because we have 100 elements. Now when you create 100 elements between 1 to 100, the intervals should look like this. It will print exactly 100 elements starting from 1 to 100. Okay. So in the next one, I'm going to discuss about creating matrices. Now matrices are 2D arrays. So let's discuss how to create matrices. In other words, we can say they are 2D arrays. So for example, if we create a capital A np.array, what you need to remember about creating matrices is you have to create a nested, in this case, arrays to define the elements in the row wise. So for example, if I say 1, 2, 3 in the first row, it looks like this. Then 4 minus 5 and then 6. Then let's say we have 5 minus 6, 7. Right? So we have np.array, we have this, and let's now print it. So we can say, okay, print A, and it looks like this. So this will, So I missed the comma here. I put a comma. So you can see I will get a 3 by 3, matrix like this.
Yeah.
So you can check a dot shape, print a dot size. Okay, so if I run this, now you can see that we have a 3 by 3 shape and the size is 9. Last one, under this, if you want to, let's say, access element. So let's say I want to access this middle element. So that means I have to access the second row. So first one is print A, 0 will be the first row, 1 will be the second row. So you see -4, -5, 6. Now the trick that we can do is within that we can have this, right? So let me put 1 and 1. So here we say A1 and 1. So when first we have A1, that will access the second element. Within that, you will access the second element. So that's what it means. So what happens? This will access the element in second row and second column.
Okay.
Right. Now, what we have just finished is discussing how to create matrices. And what you need to remember is we will have a list of lists or nested list within the NP array method, and which will create a matrix. And each row will be indicated separately. So row wise, 1, 2, 3 in the first row, then 4, -5, 6 in the second row, and so on. The next part that I would like to discuss is generating matrices, right? Now, one thing is you can always use help to understand what is going on. For example, if you say help np.ones, this is one of the methods that we are going to discuss. So, for example, it says ones shape, right, in sequence like this, data type, order, like, and the output will be a n-dimensional array. So one's method could be used to give value 1 to each element in a matrix. Now, for example, if I say so, we will say import numpy as np, and if you say print np.once, the method, and if you say just let's say 5, this will generate a vector with a size of 5, but it will fill with 1. Similarly, let's print so when you put it like this, so you can see here we have a 3 by 1, that is column vector. But notice that this is a floating point. But let's say I need integers, then this is how we should be typing. So we can say print np.once, let's say 3, 1, comma d type equals int. So this is how you may, if you're wondering that when you get numbers with decimal point, if you just need the whole numbers, you can call any element.
Every day. Every day.
So now here we have 3 by 1, 3 rows and 1 column. That is column vector we have generated, which we will fill with. So which fills with 1. Right. Okay. Using ones, can you create okay, I will give you the what you're supposed to do. Generate a vector size of generate a vector size of 2 by 3 and data type. So we want to generate a vector size of 2 by 3 with the data type as, let's say, int. So how do we do this? We can, let's say, C np dot once. Okay, now usually you can type the way we want, let's say 2, 3. We can say D type is int. So when you say print C, so you can see now, when you change this data type attribute, you can decide how it appears. So since we say data type is int, now it will show us as a small matrix which filled with 1. Right. Now, similar to ones, there's a function called zeros as well. For example, let's say I'm going to create np.zeros. Let's say 2, 3. Data type. We have data type, and then we will say it. So let's put data type is int, and let's say print C. So this time we put zeros, and you will get a matrix filled with zeros if you use 0. Right. Now, similar to ones and zeros, there are other methods as well. For example, you can try identity matrix using I, and then you can use filled with the numbers, you can use random.read.
No.
Right. Let me explain identity matrix. So identity matrix, we know that diagonal should be 1, the remaining will be 0. So we can simply say, okay, we are going to add it to print np dot 3, d type. Okay, now you can see we using linspace. We discuss how the matrix populate like this. Okay, next one. Right. The next one, let's put up some random numbers. There are two methods I would like to discuss under random numbers. You can use it from a uniform distribution, or you can have a secondary normal distribution. So let's create. So I'm going to call it what? We have random numbers. Random numbers from a uniform distribution over 0, 1. Random numbers with a uniform distribution over 0, 1. 0, 1. So this is what we are going to do. So how do you do that? Let's take some. Right now that we have discussed about the random numbers, you can try a simple one, np.random.rand 5. This will create 5 elements, and let's say print C. That's done. So you see, it's just basically a random set of numbers. Right. Can you extend this work? Can you extend this work to create a random matrix with 3 by 3? Let's start. Okay, let's create a matrix. So let's say, let's create a 3 by 3 matrix with again uniform distribution. So what we can do is, let's say I'm going to have matrix C. I'm going to say np.random.rand. We can say, okay, 3 by 2. And we can say, okay, print C. So now you can see we will get a random matrix, and the dimensions are 3 by 2 matrix. Yeah. Right, let's move to the next one. So now there are different distributions we use. The early one, we said uniform distribution. So there's another method where we can generate random numbers. Random numbers from standard normal distribution. So for example, if you want to create a vector, friend n, you can say 5. Okay. And then we'll say print C. So that vector will create like this. So earlier the values were between 0 to 100. Now you can say 0 to 1. but then you cannot have negative ones. We have here, but not in the previous one, the value between 0 and 1. Okay, similarly, let me create another one. Let me say C, capital C, np dot random dot rand. Right? We can put the comma 2. Let me print. Finish up to this point. Can you raise your hands? Some random integers. Now, if you want to create some random integers, we can use the method called randint. For example, if you have C, let's say np dot random dot rand int 1 comma 100, and let's say print C. So you will get a random number between 1 to 100. So let me rerun. You can see the value will be changed and it will be between 1 to 100. So if you want, let's say 10 elements, we can see np dot random rand int. So we will say 1 comma 100, and let's say 10 data points. We will have print C. So this is how we can get, a predefined set of values. In this case, we expect to have a random integer between 1 to 100. Right. Now that we discuss how to represent vectors and matrices and how to generate vectors and matrices, we can discuss further. Now, for example, let me explain how we can access element when you have the values in an array. So to do that, right, let me create a matrix called X. So let's see how we are going to do this. Array method. Right. So what we have is 1, 2, 3, 4. So this should be also square brackets. Okay. 5, 6, 7, 8, 9, 10, 11, 12. So you can see we print like this. Let's print X. And let's print shape as well. Okay, now that we have discussed about creating array method, and we discuss it how to convert to the right. So matrix form, when we say get image shape, it will say how many rows and columns. Right, now let's discuss how we can use index in short form so that you can access whatever the elements that you want to access. Right. So now this is X, I'm going to use the same previous one. So what we could do is we can create a vector which is 2 and 3 like this. So what happens here, we are trying to access the row. 2 means the third row. 3 means the fourth column. So if you say print, so you can see. So it says third row, fourth column, 12, right? So in this form, we are specifying both the row and column, and then we can use it for other purposes as well. Now, for example, once we that, right? So we can have it in the third row. So I can say, okay, everything under, and then we can have colon. So this will show us only the second row. So you can see, sorry, second, not second. When you say 2, it should be third row. If you want to access the fourth column, then what is the command? Yes, try and let me know. So let's try to access. So this one access third row. Let's access fourth column. I hope you remember that under the slicing, we discussed this format of using this. So when we say fourth column, we can say, okay, print X, we can say everything. Fourth column, that means the index is 3. So we will get this.
Okay.
Right. Have we finished up to this point? Right. So let's look at the next is submatrices. So in this one, I'm going to copy the same matrix again. So let me copy from here, right?
Fourth one?
So what I'm going to talk about is submatrices.
Fourth.
Now, when you are getting submatrices, remember it will be a view of the original. So I will explain what this means. Now, for example, if we have X is like this, it's a 4x4 matrix. So let's say submatrix. So we can say, okay, I'm going to take the second row and third row. So how do you do that? We can say x1 colon 3 and then 1 colon 3. So this will give you a 2x2 matrix. So when you print X, you can see the next I will say print Y. So you can observe X is a 4x4 matrix, whereas Y is, yes, 2x2 matrix. I'm going to assign everything into 0. So this is how I'm going to say colon comma colon means everything. I will assign 0. Now what happens? If you print Y,
Is it out?
yes, when you say the Y becomes 0, and let's try what will happen to X. Yes, you can see if you compare with the original, the middle elements become 0 due to the assumption that we have used. Right. Now what this means? That when you are getting directly a slice or submatrix, and if you change the value of that, it will affect the original as well. So you see here what we did, we get Y and then we set Y to 0, which eventually you will see that those values are set to 0. So now the question is, if you need a copy, not the original one, because when you change something in the original, it affects. So therefore, the second part that we are going to discuss, right? Let's say getting a copy, and we can say, okay, I will, get the same one for the easiness. So let me take this, right? I put that. Okay, so here is the X, which is 4x4. Now, when you want to get the value, remember you have to say Y equals X second and third rows and the columns and use copy method. So now we will take a copy. So now we can say here, copy of X. So let's print Y. Let's set it to Y. We'll set it to 0. Now let's print Y. Now print X. And when you do successfully, you see here, the first one shows you the print Y, and we set Y to 0. And then you have print Y and then print X. We have print Y and print X. Right, if you have finished up to this point, can you please raise your hands? Right, thanks everyone. Now let's look at another interesting one. So especially when you want to check the elements in a vector or matrix, we can use this, the next technique that we are going to discuss. So what happens here, this is also known as fan indexing. We can check the values. So let me explain this with creating a simple vector. So let me say this is called fancy indexing or Boolean indexing. So these are the words we use. So let's take this one, np.linspace 0, 1, 11, and let's print A. So you see there are some set of numbers from 0 to 1, right? And then there are 11 points between 0 and 1, including those. Now let's check what are the values in here are greater than 0.5. So the trick that we are going to use, we will check A greater than 0.5. So you see from this point onwards, we should get it, right? And then what you're getting is whether true or false, and you can see last 5 elements here will represent true. Right now, if you want to retrieve particular value only, then what we have to do is we have to say print a greater than 0.5. So you see here, it consists of 0.6, 0.7, 0.8, 0.9, and 1. Right. I hope that is clear to you. When you're finished, please indicate by raising hands, then I can just go to the next session. Right. Now let me explain another important one. The next one that we are going to discuss is called reshaping. Now I hope you remember that in previously we create a matrix called 1 to 16, a 4 by 4. Right? Now that we can use a reshaping. So reshape means we can change the dimensions. For example, when you get some financial information, it could be 2D. Then maybe we have to make it 1D likewise. So in this example, we'll say we have X in P dot A range. We can say 1,17. So now let's print X. So you can see we have numbers from 1 to 16 consecutive numbers. Right. Now to change this to a 4 by 4 matrix, you can use reshape in P dot A range 1,17. Reshape. So now we will get a range, start and stop, reshape. Okay. So reshaping, we had to give the dimension, let's say 4,4. Now that we are going to this, let me check. Okay, now you can see it's formed as a 4 by 4 matrix in our notation.
Man. Man.
So reshaping is very, very important, especially when you have 2D images. Sometimes we will make it 1D, 1D back to 2D. So we can use that reshaping. Okay, to explain the next part, let's look at how we can amend the matrix. Yeah.
People present.
So let's look at another reshaping example. So let's say we will get, for example, print NP a range, let's say 12. Of course, what will happen? You will get values starting from 0 to 11. So there are 12. So let's reshape it. So dot reshape. Okay, let's reshape to 3 by 4 matrix. So now you see it is reshaped into 3 by 4 matrix. So as you can see, when you want to generate vectors and matrices, the reshape can be used. Okay, the next part, what we are going to discuss is how we can amend, right, a matrices. So let me take an example. So this time I'm going to say X, a 4 by 4 matrix, numbers starting from 1 to 16. So I can say it P does a range. I can say 1, 17. So when you say print X, okay, we will have the values from 1 to 16. So let me put into 4 by 4. So in that case, we have to say a reshape. We can say 4, 4. Now you can see X is a matrix, which is 4 by 4. Reshape spellings not correct. Yeah. So you can see we have a 4 by 4 matrix. If you want to change one element, let's say we'll change the first element, very first element, this one. So how can we access it? We can say X 0, 0. If you use 0, 0, you will see that is 1. So let's make it to change. So what I can do is I'm going to say, okay, X 0, 0 should be equal to 10. So this is how to manipulate this. So let me print X again. If you print it again, so this time you will see in second one, the first element is now change it to 10. Okay, let's change the column values. So let's change the second column to 2. So how do you do that? So second column, so how do you say that? X, we can say, comma 1, second column. We can make it to 2. So when we say X, yeah, you can see the second row now. Sorry, second column, change it to 2. So now the next one, let's change the row element to 3. So let's say, sorry, in this one, we have to change, when you say 3, that means the 4th row, right? So let me make it to 3. So let's print X. So you can see now things have changed, columns and the rows also change, right? Which affects this. Last one, if you want to change everything, we can say X colon comma colon, which is 0. And when you say print X, you can check and see the values.
I put the second one. It's like future.
Right. Now that we have talked about amending matrices, let's try to concatenate them. The small set of matrices, we try to glue them together. So let's see how this will goes.
Yesterday you done that.
Right, now you can see how we can actually manipulate this. So let's look at the concatenation data. So here we have 4 3x3 matrices we are going to create. So let me say A equals NP dot array 1, 2, 3, 4, 5, 6, 7, 5, 9. So let's print it. Right, this is how it look like. Similarly, create several other, say that B, C, and D. So let me put B. We have 3, 2, 1. So we have 3 by 2, 6, 5, 4. These are just random numbers. Yes, we have 3, 2, 1. So let me run this. So let's make it print B as well.
Yeah.
So you can see there are 4 by 4, sorry, 3 by 3, 2 matrices. So let me put C as well. C equals array. Two, 1, 3, 5, 4, 6. So let's print C. You see how it works. And similarly, we can have D as well. Five, 6, 4. 8, 9, 7. So now you can see we have defined 4 3 by 3 matrices. Okay, so now that we are ready, we can make concatenation. So a couple of ways we can combine. Right. So concatenation can be done in various ways.
I know, right? It can mean that there are